Okay, folks, I finally have time to make a video about our spreadsheet. Now, you don't have to do this on a spreadsheet. It's just going to be easier for me to do it on a spreadsheet. So I'm jumping straight to Excel. However, everything I do on Excel, you can absolutely do on Google Docs, on Google Sheets, really. So follow along the basics of the math. Okay, with that in mind, so you can see right here, I have some stuff that I don't necessarily need, but here we are. Here's the chemical equation. That's 6I minus plus bromate and 6 protons goes to 3 I2s, 1 bromine minus, and 3 waters. And then those 3 I2s, in the presence of 6 S2O3, 2 minuses, goes back to 6 I's, I minuses, and 3 S4O2s, minuses. Now, so that's the chemical reaction we're studying. Now, this is chart right here. You don't need a copy, but it's going to be there for helping me in the math, help you show you where the numbers come from. And this is the volumes we use of each of the things in each of the trials, each of the mixtures, and there's the relative concentrations. And so hopefully you have something like this, where you have your numbers, elapsed time counted in. So one thing to note, the first thing we want to do is convert our time into seconds. So 2 minutes 30, that is, a minute is 160 seconds. So 2 minutes is 120, so 150 seconds. 135 would be 155 seconds. 227, and here I can do this if you can't do the mental math. Here's how I go about doing the math. Equals, I hit 60 seconds in a minute, there's 2 minutes, so 60 asterisk 2, that's 60 times 2, then I add 27 seconds, that would be 147, 60, 70, oh God, and that was, I'd like to say that was, $34. I don't know. Yeah. It did sound weird. So 34. We'll just say that. I may have deleted the numbers we need for that. But let's see. Do I have it in my trash box? Let's see. Did I delete that? Okay, I have it saved somewhere. Give me a second. 32 seconds. My bad. 32 seconds. Okay, that in mind. And you hopefully have something like some sort of temperature and some sort of values that we did at different temperatures. Room temperature 1 will match up with your trial 1 back up there. Now, some of you will have cold numbers, some of you won't, and that's fine. But okay, so first thing we want is the average of these. To do an average, you can either add them together and divide by 2, or I can say equals, and then in parentheses equals and say average, A-V-E-R-A-G, and hit a parentheses, and you'll notice it says number 1, number 2, and ... So I can select however many numbers I want. So I'm grabbing and dragging those 2 boxes and then hit end parentheses to say that's where I want the average to stop. So I get an average value. So there's easier ways to do that, but I'm showing you the power. If I had 100 numbers, I could average 100 numbers. Now, going back up to here, what is my total volume? My total volume will be the sum of all of the volumes. for a trial. So I can hit equals sum in parentheses and highlight all these values in parentheses. So sum 50. Now, one of the cool features of Excel and Google Sheets is that since I'm referring to boxes and not numbers, I could have a repeating equation. So you'll see here as my mouse hovers over this, it goes from this fat plus to, when I move it down to the corner, it goes to a very skinny plus. When I press down on the corner, the skinny plus, I can drag this cell down. And what that does is, so I'm taking this sum, this one's the sum of B5 through F5, and this is the sum of B6 through F6, B7 through F7, B8 through F8. So if these numbers didn't add up to 50, it would calculate my new volume. Now, this first boxes, it says calculate your concentrations. To do that, we need M1 times V1 equals M2 times V2. Well, my M1 is my relative concentration of our component for that trial. That will not change. The V1, which may change, is the volume we mixed in. The V2 is our total volume, so we're putting in this box our M2. So equals, and I'm going to highlight this guy. And I'm going to times by, so asterisk times by this guy. And I'm going to divide by this guy. Now, if I drag this down, I'm going to run into a problem. The problem is, when I drag that down, instead of referring to C3, C5, and H5, it now refers to C4, H6, and C6 and H6, which there's not a number there. So I don't want to change my M1. So how do I keep my M1 the same? Well, there's a little thing that tells us to not change boxes, and that is the $sign. The $sign tells us whatever label on that box to always keep that, whatever precedes that $sign, the same. So I can say always C, always 3. So $C, $3. And then times by the box that was my volume divided by the box that is my total volume. Now when I drag it down, it goes back to normal. So because C3 stays the same, but the C6 and the H6, the C7 and the H7, C8 and the H8 stay the same. The same thing for my iodine. I'm going to select the iodine box, times by its volume, and divide by its total volume. Once again, we're going to have a problem in that if I drag that down, I'm going to lose that concentration. But if I say always B, always 3, that will be fine. Now when I drag this down, you notice trial 2, the concentration has doubled. But trial 3 and 4, it will have gone back to how it was. And that's because the volume will have doubled at trial 2 versus trial 3 and 4. So that should keep that in mind. Doing for bromate equals always E, always 3 times E5 divided by H5. And this, you could do this in your calculator, just dandy. You don't have to do it like I'm doing it. I'm just showing you how this would work. And that equals always F always 3 times F5 divided by H5. And that, and I drag that down, that will only change on the last value. And if you're like, well, if you click into this bar, it will highlight the relative boxes. So in blue, it says, well, there's the F3 times there's the F5 in red divided by the H5 in purple. And so you can always see where a box is referencing. So I now have my relative concentrations for all 4 trials. Then it asks, well, how many moles of S2O3 react for every 1 mole of bromate? So let's scroll back up to the top. Well, when reaction 1 happens, 1 bromate consumes 6 iodine to form 3 iodine. For every 3 iodine, 6 thiosulfates turn it back into 6 iodides. So for every 1 bromate needed to consume the first reaction, 6 thiosulfates convert it back. So we need 6 moles of thiosulfate for every 1 mole of bromate. So that means in the ratio, A is 6, I think B is 1. I could be wrong, I could have it flipped, but I'm pretty sure that's, the idea is that the rate of bromate consumption is 6 times faster than the rate, well actually the rate of thiosulfate consumption is 6 times faster than the rate of bromate consumption. That's what that says. So to get a rate for a trial, you're going to take a concentration of thiosulfate. So because I have this in the table right here, then I'm going to divide it by my time. Well, what's going on? I screwed something up. Let's see. 227. Yeah, okay. That shouldn't be 147. That should be 152.5. I don't know why I have. Someone gave me bad numbers. Okay. Shame on them. But okay. So you're going to take a concentration and divide it by a time. That is your relative rate of decomposition. Now, because this concentration doesn't change, that's going to stay the same. So the only thing that's going to change is the time. Now, because I have it set up perfectly, when I drag this down, I'm going to divide this concentration by a new time each time. So divided by this, divided by this, divided by that, divided by that. And there's our relative thiosulfates. Now, the rate of thiosulfate to the rate of bromate is, as I said, 6 times faster. So we're going to take whatever I have in this box and divide it by 6. Divided by 6. And so we get this number right here. So I divide this guy by 6, divide him with this guy by 6, by 6, by 6. Now, we are going to just copy our numbers over. So I'm going to highlight these and just say, I'm going to copy these down. And I'm going to, here's a key, paste special. I want just numbers. I want paste special. And I want the values, not the equations. Because if I do the equations refer to boxes that don't have the right things. But if I paste special the numbers, the values, it's going to just copy whatever was in those boxes, and we're good. The same thing, I'm going to highlight these, copy, and paste special down here. Of course, you can copy them by hand just fine. So, the next part asks us, what is the order with respect to I2? So, I'm going to look at T2 divided by T1. So, the rate of the second divided by the rate of the first is what? And then the I of the second divided by the I of the first. So this divided by that gives me this. And this divided by that gives me this. Okay, we don't have a 1-to-1 ratio. So the question is, what is our order with respect to I? You might be able to eyeball it, but the best way is to take a logarithm. So let's do the log. So I do this. I could type equals log10 and highlight this number. And equals log10, highlight this number. Once again, it's still not a 1-to-1, but now we divide this guy by that guy. So the simple ratio. And so we get the ratio is something like 1.34, which is 1.34 rounds down to 1. So essentially, in our case, in this guy's case, this student's case, it's first order with respect to iodine or iodide. Now let's look at bromate. So I'm going to look at T3 over T1. So I'm going to look at rate 3 over rate 1. BrO32 divided by BrO31. I say it's BrO33. So equals, okay, what's my bromate here divided by bromate there? 2. What's my rate here divided by my rate there? About 2. Copy these things over. Well, what do you know? When I copied that over, because I have this set up in the exact right spot, it works its way out perfectly. And then I'll do this one more time. T4, T1, rate 4 over rate 1, H4 over H1. You can see where this is going. I'm doing this one more time, and he goes. Now, this person's numbers may not match your numbers, so check your numbers. Do your thing. Now, I'm going to copy this over one more time. So that's about 2. So their rate law. So the next part is putting the rate law. So this student's rate law equals rate equals AK first order in I, so I raised to the 1 times BrO3 raised to the 1 times H raised to the 2. So first order in I, first order in bromate, second order in protons. So with that in mind, to get the K, we are solving an equation, so rate equals this. And I have concentration. So to find our K for trial 1, I'm going to say equals my rate, and I'm going to divide by my I concentration. I'm going to divide by my bromate concentration, and I'm going to divide by my H plus concentration squared. Now, the easiest way to square that is to, say, write the caret, which is the shift 6 key, and 2. You could just divide by my H plus concentration twice. That would also work. But that is the easiest way to do that. And so I have a rate constant. Now, because of how I set this up, I can't just copy it over. Because if I drug this over, it would move it, shift it to the right, not shift it down. And I want to shift it down. So if I divide this by that, do it 2 more times. You see why I'm doing this on here, not the calculator? I don't have to punch in these numbers each time. I can just do it like this. And so equals the rate divided by this, divided by this, divided by this, caret 2. So I have 3 K constants. So my average K is going to be equal to average, and I'm going to highlight these. Now I have 4 values, and I can do the average perfectly. So my average K is 38.86. So that is that is essentially the math you're doing for part A. Part B is we're going to plot this. So I'm going to show you how to do this. We need our times, obviously, in seconds. You need your temperatures, but we need them in Kelvin. So I have 3 values, so I'm going to say equals this number plus 273.15. 273 is probably good enough. So I'm plugging those in. Now, because we have a rate law, we can do this pretty easily. So our concentration of S2O3, we're going to say divide that by my time. Okay, that's not going to change. Divided by my time equals concentration there divided by my time. Once again, to get that, you're going to times that, you're going to divide this by 6. I can just drag that over because it's the same equation. Divide that by 6. Divide that by 6. Now our K, to do our K, we have to assume the rate law stays the same. So the rate law here stays the same. So since it's all trial 1, we're going to take our rate divided by 0.002, divided by 0.008, and divided by 0.02 squared. And so I'm just dragging that over. There's my K constant. My K constant jumped up a huge amount, and it jumped up even more. Finally, we need a natural log of K and a 1 over T. So natural log is a ln. And I'm going to highlight this. I can drag that over. And 1 over T is just going to be 1 divided by my temperature in Kelvin. And I can drag that over. So I have plottable data. Plottable data. Just remember, you want the 1 over T in the X column. So I'm going to say my X column and my Y column, X is going to be equal to this. Actually, here's a neat trick. We can transpose this data. So if I copy this, I'm going to right click and I'm going to paste special. Let's see. I'm going to paste special, and I'm going to, in this case, I want to values and numbers, and let's see. I'm going to cut, and let's see if it'll let me transpose this. And no. Put that back. I'm going to copy, and one of the things you can do is paste special. Let's see, formulas. So it's format transpose. So I can transpose that so it's now scrolling down instead of scrolling across. Copy, and then we're going to transpose that. Now you can just type it in or just say equals that box. Either one would work. So now the trick is to plot that. So I'm highlighting those boxes. Google Sheets is going to be slightly different, but one way or another there's usually some sort of graph button. And on Excel it's an insert. You can insert chart and you want an XY scatter plot. In Google Sheets it's going to be a little bit different. But so with this I have a chart. I have the ln on this chart and the 1/t on this chart, and I want to add a chart element. So I usually select the data and I want to add a trend line. There's various things you may have to fool around to get it, but you want to add a linear trend line. One of the key things is you want to display equation on the chart, and you want the r squared value. The closer to r squared to 1, the better your data fits your line. Though don't get cocky if you only have 2 data points, because of course your data is going to fit your line perfectly if you only have 2 data points. But the closer it fits to 1, the better the data fits the line. Now with that in mind, so my equation for this line is equal to y equals negative 10994 x plus 41.141. So my slope is negative 10994. My y-intercept b is 41.141. With that in mind, the equation reads the y-intercept, the slope is negative EA over R. EA over R. Oh, dang it, I don't want to do that. Okay. Negative EA over R. And the so R being 8.314. Don't worry about that. So let's just put EA over R times negative 1. And that's our slope. Our y-intercept is ln of our A. So if I wanted to figure out my A constant is going to be equals the EXP, and I'm going to highlight this number. That can give me my A constant. My activation energy is going to be equals to this number times negative 8.314 divided by 1,000 to get this into kilojoules. So in this particular student, we got something like 91 kilojoules activation energy and a collision factor of 7.36 times 10 to the 17th. But that is how you'd go about doing that. So in this last one, if you can get your rates, the rates is all the same as how you would have done it on here. As long as you can get your same K as you would have got there, you're just doing the same thing. But we have to plot this. So we're plotting the 1 over t as the x value and ln k as the y value. If I wanted to label this chart, I could label it. But that's essentially what you're doing. That's what you're doing. If you can do that, you've done the most mathematically hard thing I could possibly ask of you. And you're smart people. I trust you can try this out and try to fiddle around. If you're still struggling, come on by. I'd love to try to sit down and help you with this. Because learning how to use Excel is an incredible time saver. Learning how to use Google Sheets is an incredible time saver. If you know how to do it, you can do a lot of amazing things with that. But okay, this is Dr. Evans signing off. See ya!